You believe you understand what you're really asking when you say, why do magnets repel? But you don't. And until you recognize why the question itself is flawed, every answer you hear, mine included, is going to leave you dissatisfied and irritated. Let me show you exactly where the problem lies. Take two magnets and bring them together, North Pole to North Pole. Feel that force, that push, that invisible resistance appearing out of seemingly empty space. You want to know why that happens. You want me to explain it by saying magnets repel for the same reason as something familiar, like rubber bands stretching, springs compressing, or two hands pressing against each other. You want a comparison that fits neatly into something you already understand. Here's the truth. There is no familiar thing to compare it to. And I'm not being stubborn. I'm not dodging the question. I'm not hiding behind complicated language. I'm telling you something most people don't like hearing. Magnetic forces are fundamental. They're bottom-level facts about reality. There's nothing beneath them to appeal to. When you ask me to explain electromagnetism by reducing it to something simpler, you're asking for the impossible, because nothing simpler exists. That's like asking me to explain arithmetic using concepts more basic than numbers. It can't be done. Now you might be thinking, wait, I've heard explanations, magnetic fields, spinning electrons. Those sound deeper. They're not explanations. They're descriptions, excellent ones, precise ones, mathematically powerful ones, but still descriptions. They tell you how the force behaves, not why it exists at all. And unless you understand that distinction, this entire discussion goes nowhere. Let me ask you something else. Put your hand on your desk right now. Go ahead. Press down hard. Why doesn't your hand go straight through the desk? Your first answer is probably because the desk is solid. That's wrong. Not because the desk isn't solid. It is, but because that answer explains nothing. It just replaces the question with a label. Try again. Why doesn't your hand pass through the desk? You might say, because the atoms are tightly packed. Better. Keep going. Why don't the atoms in your hand pass through the atoms in the desk? You might say, because atoms are solid too. No. Stop there. Think carefully. Atoms are not solid. In fact, atoms are mostly empty space. If you blew up a single atom to the size of a football stadium, the nucleus would be like a tiny pea sitting at midfield. The electrons would be microscopic specks whirling out near the seats. Everything in between would be emptiness. Your hand is almost entirely empty space. The desk is almost entirely empty space. So why don't they pass through each other? Now you're starting to feel uneasy. Good. That discomfort means you're finally asking the right question. The answer is electromagnetic repulsion. The electrons in your hand and the electrons in the desk carry the same electric charge, like charges repel. When you press down, you're experiencing trillions upon trillions of microscopic electromagnetic interactions, all summing together into what you call solid matter. Now here's the question that really traps you. Why do like charges repel? You can't answer that, can you? You can say, because of the electromagnetic force, but that's just naming the thing. That doesn't explain it. Saying magnets repel because of magnetic force is circular reasoning. It's like saying opium makes you sleepy because it has a dormitive virtue. The electromagnetic force is one of the four fundamental forces of nature. It isn't caused by something else. It doesn't emerge from a deeper mechanism. It simply exists. And here's the part nobody ever tells you clearly. The force that stops your hand at the surface of the desk is the exact same force that makes magnets push apart. Not similar, not analogous, identical. The electromagnetic force. So why does one feel obvious and the other feel mysterious? Here's why. You've been pushing on solid objects since you were a baby. By the time you were 2 years old, your brain had accumulated a massive library of physical experiences, pushing, grabbing, falling, bumping into things. Your neurons wired themselves around those interactions. They formed expectations, patterns, intuitions. So when you push on a desk today, it feels normal, natural, self-evident. You don't even think of it as something that needs explaining. Magnets are different. Magnets push through visible space. You can see the gap. You can slide a piece of paper between them. There's nothing there that feels strange, that feels wrong, that feels like it demands an explanation. But here's the truth. The strangeness isn't in the physics. It's in your mind. When you push on a desk, the electrons in your hand never actually touch the electrons in the desk. They repel each other across a tiny distance, just a few atomic widths. We call it contact only because that distance is too small for you to see. In reality, nothing is touching anything. It's electromagnetic repulsion acting across a gap. With magnets, the gap is larger, millimeters, centimeters, large enough to see, large enough to unsettle you. But the force is the same. The mechanism is the same. The only difference is scale. The mystery you feel is psychological, not physical. You're comfortable with electromagnetic repulsion at atomic distances because you've lived with it your entire life. You're uncomfortable with electromagnetic repulsion across visible space because it's unfamiliar. That's the whole difference. Now you might think, all right, but surely quantum mechanics explains why the electromagnetic force exists. No, it doesn't. Quantum electrodynamics, the quantum theory of electromagnetism, is the most precisely tested theory in all of science. Some of its predictions have been confirmed to 11 decimal places. Nothing else even comes close. But what QED actually does is tell you how to calculate electromagnetic interactions with astonishing accuracy. It gives you equations, rules, predictive power. What it does not give you is a deep philosophical reason for why the electromagnetic force exists at all. It describes the force perfectly. It does not explain it away. It cannot reduce it to something simpler because nothing simpler exists. Let me show you how this always works with a different example. You ask, why does ice float on water? I answer, because ice is less dense than liquid water. You ask, why is it less dense? Because its molecular structure leaves more space between molecules. Why does it have that structure? Because of the way hydrogen bonds arrange themselves when water freezes. Why do hydrogen bonds arrange that way? Because of the quantum mechanical behavior of electrons in water molecules. Why do electrons behave that way? Because of the Schrödinger equation and the Pauli exclusion principle. Why do those equations hold? Now notice what's happening. Each answer feels deeper, but I'm also just pushing the question back one level each time. Very quickly you hit bedrock, the fundamental equations, the basic forces. And there, the only honest answer is this. That's what the universe does. We can measure it, we can describe it mathematically, we can test it experimentally, we can use it to make predictions and build technology, but we cannot explain it in terms of something more fundamental, because there is nothing more fundamental. The chain of why has to end somewhere. That's the real problem with your question about magnets. When you ask why, you're not really asking for knowledge, you're asking for comfort. You want the unfamiliar connected to something familiar so you can stop feeling uneasy. You want a story, a neat causal chain that ends in something you already understand. But magnets repel because of the electromagnetic force. And the electromagnetic force exists because that's how the universe is structured. There is no deeper story, only measurements and mathematics. I know that's not satisfying. I know you want more. The universe doesn't care. Here's what actually bothers me about this question. You're treating magnets as if they're the weird exception in an otherwise normal world. That's exactly backward. Everything is electromagnetic if you look closely enough. Why do chemical reactions happen? Electromagnetic forces rearranging electrons. Why does light reflect off mirrors? Electromagnetic interaction. Why do you see colors? Electromagnetic radiation striking your retina. Why does your computer work? Electromagnetic forces pushing electrons through circuits. Electromagnetism isn't some exotic phenomenon that only appears in magnets. It dominates your entire existence. Gravity is weaker by a factor of 1036, irrelevant for atoms and molecules. The strong and weak nuclear forces are trapped inside atomic nuclei, acting only over tiny distances. Everything else, everything you touch, see, and interact with, is electromagnetism. The force pushing magnets apart is the same force holding your body together right now, the same force keeping you from falling through your chair, the same force allowing you to read these words. So when you ask me to explain magnetic repulsion using something normal, you're asking me to explain electromagnetism using electromagnetism. It's circular. It can't be done. Let me try another angle. You know how you explain the color blue to someone who can see? You point to the sky, a shirt, an ocean, but how do you explain blue to someone blind from birth? You can talk about wavelengths, around 450 nanometers. You can describe its place between red and green in the spectrum. You can give them all the physics of light, but none of that gives them the experience. They have to see it. There is no shortcut. Magnets are the same way. So is electromagnetism. You don't gain intuition from a clever analogy or a 5-minute explanation. You gain it by working with the mathematics, solving problems, making calculations, testing predictions. After months, sometimes years, of working with electromagnetic theory, something changes in your brain. The equations start to feel natural, obvious, not because they resemble everyday experience, but because you've built a new kind of experience, mathematical experience. And then magnets stop being mysterious. They become exactly what you'd expect, inevitable consequences of charged particles and fields. You can't skip that process. You have to earn the intuition. Now here's what I can give you, the technical answer. Magnets have magnetic dipole moments, tiny arrows of magnetism. When many of them align in the same direction, you get a permanent magnet. Those dipoles create a magnetic field configuration that stores energy. Physical systems evolve toward lower energy states. When two north poles face each other, the energy is high. Moving them apart lowers the energy, so they repel. That's the answer. That's as deep as it goes. You want to know why dipoles create fields? I can talk about moving charges and electron spin. You want to know why electrons have spin? I can point to the Dirac equation. You want to know why the Dirac equation works? Because it combines quantum mechanics with special relativity. You want to know why those theories hold? Because they match reality. Because we've tested them relentlessly and they work. That's where it ends. Here's how physics actually operates. We don't start with philosophy and derive the universe. We start with measurements. We observe patterns. We write equations that describe those patterns. We test those equations against experiments. When they work, when they predict things we haven't seen yet, we say we understand the phenomenon. Understanding in physics doesn't mean emotional satisfaction. It doesn't mean matching intuition. It means predictive power, the ability to calculate, to build, to control. By that standard, electromagnetism is one of the best understood phenomena in existence. Quantum electrodynamics is tested to astonishing precision. We can calculate the magnetic moment of the electron to 11 decimal places, and experiments agree exactly. So when I say I understand magnets, I mean this. I can calculate the forces. I can predict behavior. I can design motors, generators, MRI machines. I can trap particles and focus beams using magnetic fields. That's understanding, not comfort, not analogy, power. You might not like this answer. You might find it unsatisfying, too cold. The universe doesn't owe you comfort. Your intuition evolved to throw rocks, pick fruit, and avoid predators, not to grasp quantum fields. When physics violates your intuition, waves behaving like particles, time slowing down, magnets pushing through space, you have two choices. Reject it as mysterious and demand better explanations that don't exist, or expand your intuition. Learn the math, solve the problems, build new mental models grounded in equations and experiments. That's what physicists do. So the next time you feel magnets pushing apart, don't ask why. Ask how. How does the force change with distance? How strong is it compared to gravity? How can I calculate it? How can I use it? Those questions have answers, beautiful, precise answers. The why that asks for reduction to something familiar does not. Not for magnets, not for any fundamental force. And here's the beautiful part people miss. Physics reveals that the universe runs on a small set of rules. The same equations describe magnets, lightning, brain signals, computer chips, auroras, chemistry, and stars. That's not a failure to explain. That's unification. You wanted magnets explained using something familiar, but everything familiar is electromagnetism. Your desk, your body, light, life itself. You're not separate from magnets. You're made of the same force. So no, refusing to give a comforting analogy wasn't arrogance. It was honesty. The truth is harder and far more magnificent. Feel that invisible push again. You're touching one of the fundamental forces of nature. That's not mysterious, that's extraordinary.